Exercise 2.4. Actually, it is mentioned as optional exercise in textbook, but I prefer this exercise. Why? Because this exercise helps in understanding and revising the concepts better. Okay. Now, first question. Verify that the number given along the side of Q polynomials below are their zeros. Also, verify the relationship between the zeros and the coefficients in each case. So, in this question, what they are trying to say, they are given a cubic polynomial and they are given some values, and they want to check us whether the given values are becoming zeros for the given cubic polynomial or not. Okay. And also check the relationship between zeros and coefficients in each case. Okay. First problem. 2x cube plus x square minus 5x plus 2, and the given values are 1 by 2, 1 and minus 2. Okay. Now, we know that alpha is equal to 1 by 2, beta is equal to 1 and gamma is equal to minus 2. And the given cubic polynomial is 2x cube plus x square minus 5x plus 2. Okay. Now, when comparing with the standard form of cubic polynomial, that is ax cube plus bx square plus cx plus d, we are getting the values of a, b, c, d as a is equal to 2, b is equal to 1, c is equal to minus 5 and d is equal to 2. Okay. Now, if a particular number or value k is said to be a 0 for any polynomial, then it must satisfy the condition p of k is equal to 0. Like in the same way, if 1 by 2, 1 and minus 2, which the values given in the question, are said to be the zeros for a given cubic polynomial, it must satisfy the condition p of 1 by 2, p of 1 and p of minus 2 is equal to 0. Then we said that these three are zeros for the given cubic polynomial. So we have to find p of 1 by 2. P of 1 by 2 is nothing but we have to replace 1 by 2 in place of x and we have to solve. Then if you are getting 0, if you consider it as a 0 of a given cubic polynomial. Now p of 1, it also has a result of 0, and p of minus 2, it also getting a result of 0. So we can clearly observe that p of 1 by 2 and p of 1 and p of minus 2, the resultant is 0, as these are the roots of the given equation. To check what is the relationship between zeros and the coefficients in each case, we know that the sum of the roots alpha plus beta plus gamma, which is equal to minus b by a, and sum of the product of roots, two roots at a time, that is alpha beta plus beta gamma plus gamma alpha, which is equal to c by a, and the product of the roots alpha beta gamma, which is equal to minus d by a. So while we comparing with the standard equation, we are getting ab values. So while you compare alpha plus beta plus gamma with minus b by a, we are getting same values. So it can clearly say that the relationship between zeros and the coefficients in each case are also established between them. Okay. Second problem. The given problem is x cube minus 4x square plus 5x minus 2, and the given values are 2, 1, 1. Okay. Now, given alpha is equal to 2, beta is equal to 1 and gamma is equal to 1, and given cubic polynomial is x cube minus 4x square plus 5x minus 2. Okay. Now when compared with the standard form of equation, that is ax cube plus bx square plus cx plus d, then we are getting a, b, c, d values as a is equal to 1, b is equal to minus 4, c is equal to 5 and d is equal to minus 2. Now if you want to check whether these three values are becoming 0 or not, then if a value k is said to be 0 for a particular polynomial, then it satisfies the condition p of k is equal to 0. In a similar way, if the given three values are said to be zeros for a given polynomial, we have to check whether p of 2 and p of 1 and p of 1 are becoming zeros or not. Okay, if the values for p of 1 and p of 2 are 0, then we consider these three are the zeros for a given cubic polynomial. So we want to find p of 2, p of 1 and p of 1. Okay. P of 2 is nothing but we have to replace 2 in place of x in the given polynomial. Then we are getting the resultant of 0. Again, if you find P of 1, it is also getting resultant 0. Hence, we can say these three are zeros of the given equation. To want to establish the relationship between the zeros and their coefficients, we know that sum of the coefficients alpha plus beta plus gamma, which is equal to minus b by a, and the product of two zeros at a time, that is alpha beta gamma plus gamma alpha, which is equal to c by a, and the product of zeros, that is alpha beta gamma, is equal to minus d by a. Hence, these values are becoming equal. We can consider this polynomial equation and these roots are satisfying the relationship between their coefficients and their zeros. Find a cubic polynomial with the sum of the products of its zeros taken 2 at a time, and the product of zeros as 2 minus 7 and minus 14. So in the question, they are given sum of their zeros and product of their zeros and sum of the product of two zeros at a time values, and they want to find us the required cubic polynomial. Okay. Given that alpha plus beta plus gamma is equal to 2, alpha beta plus beta gamma plus gamma alpha is equal to minus 7, and alpha beta gamma is equal to minus 14. To find the cubic polynomial when alpha beta gamma are given, there is a formula for general equation, that is x cube minus alpha plus beta plus gamma into x plus alpha beta plus beta gamma plus gamma alpha into x square minus alpha beta gamma is equal to 0. Hence, if you substitute the values of alpha beta gamma in this equation, then we are getting the required equation as x cube minus 2x square minus 7x plus 14 equal to 0. Okay. Next problem. If the zeros of a polynomial are a minus b, a and a plus b, find a comma b. So, given there is a cubic polynomial and given that the zeros for the cubic polynomial are a minus b, a and a plus b, then they are asking us to find the values of a comma b. Okay. So, when compared it to standard form of equation, that is ax cube plus bx square plus cx plus d, we are getting the values of a is equal to 1, b is equal to minus 3, c is equal to 1 and d is equal to 1. Okay. Given that alpha is equal to a minus b, beta is equal to a and gamma is equal to a plus b. So sum of the roots alpha plus beta plus gamma, which is equal to a minus b plus a plus b, which is equal to 3a, and alpha beta plus beta gamma plus gamma alpha, which is equal to 3a square minus b square, and alpha beta gamma, that is product of the roots alpha beta gamma, which is equal to a minus b into a plus b, which is equal to a cube minus b square a. Okay. Now, the general equation is x cube plus alpha beta plus gamma x square plus alpha beta plus beta gamma into alpha gamma x minus alpha beta y. Okay. Now, if you substitute the values, the equation become x cube minus 3x square plus 3a square minus b square into x minus a cube minus b square into a. So, when it is compared with the equation which they are given, we can clearly note that minus 3a is equal to minus 3. That is, a is equal to 1. And if a is equal to 1, 3a square minus b square is equal to 1. Then we are getting the b square value as 2. B square is equal to 2.